Hello everyone, welcome back to the channel. Today we're going to play around with this again. This is the Arduino Pro Micro, and last time we got to play around with it really quickly and just be able to enter some keyboard and mouse movements. Today I want to really build this into something a little more concrete. It's not going to be super polished, like I don't have an encasing for it or anything, but I'm hoping to put this somewhere on this breadboard and have a couple buttons on the side so that we can have a couple macro keys, basically programmable macro keys. The very first step is we're going to do a bit of soldering. We are going to take these headers. Let's do this on camera and do a bit of soldering here. So let's see if you guys can see this. Close, there we go. So what you want to do is solder each one so that this piece is affixed to the Arduino, and then you can, well, you have a second piece down here, and then you can attach it onto your breadboard. If you so desire, I suppose you can wire the buttons directly onto this board right here, but I want to put this on a breadboard so that I can reuse it later on. I can just pop the buttons out, reprogram this, and do whatever I need to do later. So that's a game plan. Quickly, I'm just going to do a bit of soldering. I'm not sure if I'm the best person to do this, but I'm the only one here. You'll see that what you need is a soldering iron. This is a very cheap, I think maybe $7 or $8 off Amazon. So, and it's also being used and abused. So you don't need anything too fancy. The pads here are small, definitely, but not minuscule. So let's see if I can find. Here is a US quarter beside it. They're small, but they're not unmanageably so. And in the background, I'm just trying to untangle wires here. Okay. You gotta make sure your workspace is clean. I say that, but my workspace is anything but clean at the moment. I've broken off a small piece of solder right here. What we're going to do is melt this onto here. What you want to have handy all the time is just like a wet sponge, or in this case, just a wet paper towel here. And since my soldering iron is nothing fancy, it's just going to heat up. There's no option to turn it on or off. But really what we're going to do is just, we're going to wait for it to heat up properly. Let's get this out of the way. Just testing the temperature here on the towel. Normally I'd hear a sizzle when it's ready. Okay. Here we go. Also, I have the window open as well. Just, you want to make sure you have the precautions ready. I don't think my speaker can pick that up, but there's a slight sizzle when I tap the moist towel here. So we're starting to get to the right point. Just gonna move this closer. Ooh. So I want to make sure that we can actually. And what you want to see is that it can melt this. And you can see it bubbling a little bit on the tip here. All right, what you want to do is just go right up to it. And touch this. And solder it right on. And see that that was not the best job, but it's turning on another light here. So I can see a little better. You have all the time in the world. You can just back on. And make sure you have good connection. Next piece. This is taking a little longer than I thought, so we're just going to speed right through this. We finished our soldering now, and you can see, these are affixed. The headers, they don't fall off because there's like a little glob of solder on each of these pads attaching it to it. If you know you're soldering, you'll see this isn't perfectly uniform. I don't know if I could have done a better job, but you should be doing a better job if you can. We have a breadboard here, and let me just explain really quickly what a breadboard is for. It's just for prototyping. You can imagine if I had this Arduino, I would have to connect these buttons with a wire, and so I might have to start soldering here and here, or here and here, and wherever. And that just takes a lot of work, especially if you make mistakes along the way. What this breadboard does is it just automatically lets you connect all along the line, down each line. So you guys can see the 5 pads I'm tapping. If you stick a wire here in this first one, it is connected to all of these other ones down that line. So say I put another one over here. These two are now connected. I don't need to solder them together. And if I make a mistake, it's just pulling it out. It's that simple. And so each line is connected. And so you want to push it in a way where that will make a difference. I didn't actually think this through. This is a tiny breadboard. I have a bunch of these and they're really useful, but it's quite tiny. You see, if I put this down here and push it in, I don't have a lot of room for these buttons. And given how the breadboard is, how they're connected, I can't really fit multiple buttons in. So what I'm going to do is use this breadboard exclusively for the buttons. Let me just plug these in. And so they each have their little legs, and you just push them in. Push them in on this side as well. And now you have buttons affixed. I'm going to push these in as well. This one's just not cooperating a bit. There we go. Okay, we have 3 really nice clicky buttons. What we want to do is connect all of these together. So I have a bunch of black wires, and what I'm going to do is connect one side of each of these buttons into the same line. Okay, so see, this will be clear. So one of the feet, it connects down to here, and I want to put them all in the same line over here. Okay, so they're all connected to one line. And where I want to connect that line to, let me just move these bottom 3. Okay, where I want to connect that line to is the pad over here that says just fiddling with the autofocus here. What we want to do is hit this one right here, the raw pad. And then each button will then separately connect to another pin. And so we have 15, 14, 16, 10. I don't know why the top row is not numbered numerically, but the bottom makes more sense. 5, 3, 4. Sorry, that's not 5. 2, 3, 4, 5, 6, 7, 8, 9. Each of these are going to show up on your computer. And so what happens is if you say connect this button to pin 4, when you click it, then you'll know that pin 4 has been clicked and you'll do something in your program afterwards. So all of these black ones, they all connect to the same row. They all connect to raw. And then what I'm going to do is just, well, hopefully get them in first. But I'm going to use pins 2, 3, 4. And, oh, it's not right. This one's pin 2, and it's connected to a green wire. 2, 3, and 4. And if in the future, you want to spread these out, that's fine. Like if you want to use pin 2, 4, and 14 just to make it easier for you to space the wires or whatever, that's not too big of a problem. Anyways, we go back here. You see on one end, we've connected. Let me just autofocus this again. On one hand, you have connected this to raw. You want to flip it to the other side and go to the opposite corner. And we have pin 2, pin 3, and pin 4. And there you have it. I could have used shorter wires, but this is going to be our Stream Deck. We're going to be clicking the buttons here and getting this ready. Again, I'm finding it annoying now that we have wires around the buttons. If you get a bigger breadboard, or if you actually start soldering these things on together, you can get a nice case for it and so on. I think what's probably going to happen is I'm going to try and move all of these to one side. But where are we? We have this, which is a micro USB port. Just going to connect a micro USB cable. It's upside down here. connected, and on the other side, we're going to connect this to the computer, and we're ready to start writing our code. Okay, so I was fiddling back and forth, and I think I realized, why did I try and save on a resistor? These are 10K resistors. Let me just pull one out from the bag. They cost like next to nothing, but my concern was more space on this breadboard. And in case you guys couldn't tell, I don't know what I'm doing entirely. But here we have a 10K resistor, and I sure hope this is 10K. You can read the colors on the bands, and it's supposed to tell you. It's in a bag that says 10K, so I'm hoping that's right. What we want to do, well, the problem that I've had all this time is that the buttons seem to think they get pressed every now and then. When I click down, it definitively knows that it's being held down or that it's being clicked once. But when I leave it up, every now and then it just randomly clicks itself. And what I think it is, well, at first I was thinking it might be the rates, it might be the pins that weren't working. And for some reason, pin 3 seemed to be okay. But my new working theory is that I'm missing the resistor. And basically, some little bits of interference is going to mess this up. So all of these are connected to power. I don't know what I'm doing, really. I don't think this is right. I thought they were supposed to be connected to ground, but let's just move it here anyways and see. see how things go. All right, where is my cable here? And it's moving here. Oh, and let's switch over to this view so you guys can see. All right, so what I'm going to do is push this back in. And fingers crossed, we have a slight delay. Let's clear the monitor. This is looking good. Normally, it would start popping out random buttons being pressed, but let's see here. Oh, no. Okay, hang on. It might just not be working at all. Okay, so I think I need a separate wire here to connect it to ground so that it doesn't get that interference. Fingers crossed that that's the actual problem. What I find very bizarre is that when it's connected to pin 3, when a button is connected to pin 3, it works, but pin 3 is a bit special. Pin 3 is at a different hertz, a different rate than the other ones. It picks up faster. That was where I was being led down this rabbit hole of trying to change the serial number, the serial rate here. That hasn't done anything at all. And so I was thinking maybe all the pins should have the same rate, something like that. That doesn't seem to be it. So I think I'm going to need to grab a few more wires and we'll just speed through this. Okay, that makes total sense, but that still doesn't make me happy. So let me just clear the output and show you guys. When I click button 1, button 1 pressed, button 2 pressed, button 3 pressed. And then you can see any of the buttons will trigger all 3, and that's because my pin are all connected to ground. They're all linked up together. And so when one of them presses, they naturally are connected to all the other ones. So I have to find a way to somehow so that they all connect to ground separately. But it seems like this does seem to be the problem. Like when I'm doing nothing, no button is being pressed. Let's just try this one as well here. Just make sure the serial isn't going to change things before we start rewiring. But take a look at that, right? All of these wires, it's starting to look like a homemade bomb or something. All right, we're done uploading, and yep, same problem. Okay, we'll speed through this. Okay, so we have gotten pretty much where I've wanted it. This has far too many cables. Let's switch to the big view first. Okay, so I was forced to use three resistors. It seems like there is this built-in pull-up resistor. Uh, for whatever reason, I think it's too, like, the built-in resistors are too strong, so these button presses aren't doing anything. So it's as if they're never ever being pressed. So I had to pull into my very limited bag. I may need some more in the future, but in any case, what is happening? Hang on 1 second. Let me grab a pen. So point at things. We have three buttons. Three buttons. Please ignore the wires for now at the top of the screen. But we have three buttons. Each one will connect to the power. And so they all on one side through these orange wires connect to one line, and that line connects to the power on the Arduino. On the opposite corner, each pin is connected to a number. So for us, I think it was 456 that I decided in the end. Yeah, 456. Now that I've played around with it, I don't think it matters at all. Like at the start, I knew it didn't matter. In the end, it didn't matter. I'm not quite sure why pin 3 was different. I suspect, like, because of its higher rate, it might already have some sort of resistor built in. Now, the other side is that each of these pins, let's disconnect this so you guys can get a better view here. Oof, that is pretty ugly. Don't worry, I will share a screen of a schematic I saw online that will help. But if you guys have a bit of patience, let's look at the orange one right here. Let's look at the orange one. The orange wire connects to the Arduino pin 6. In that same line, it goes sideways. So these two, it just puts it to another row. It puts it to its, it connects that orange pin to a separate row all on its own. And in that row, I have the resistor, the 10K resistor, connected to ground on this side. So all of these resistors, they all connect to their pin independently, and then they all come to this line over here, and finally this final line goes to ground. And that makes no sense whatsoever. I will show you in the schematic in just a second. But the other thing about working with this really compact breadboard is that these resistors kept touching each other and just not working. So for now, super low tech. I just have pieces of paper in between them so that they can't touch each other. I'm really thinking I'm just going to get a bigger breadboard for this once it's all done. But for now, eh. Okay, what was I saying about all of that? Well, here is the schematic. Obviously, we're using a slightly different board here, and they have much more room, but it's the same thing. Each of these pins are connected on one end to their pin numbers, and then on the opposite side of the button, they're all connected to one row, which connects to power. Finally, each of these pins over here are connected to their own resistor. And finally, that resistor is connected to ground. Okay. Now, what can we do with this? Well, now that it's finally working, oh, of course, I unplugged it. Upload it. Okay. And we'll serial monitor it. So now it's like a console. It's trying to pick up what's happening. Nothing is happening. Oh. Nothing is happening because I am not pressing anything. But as soon as I press 1, button 3 is pressed. Button 2. My screen seems to be lagging a bit, but it is detecting it as soon as my button presses. So you see a bit of delay in the video, probably just my video capturing software is running a bit behind, but as soon as I press these, the serial shows that a button has been pressed. Try that. Yeah. So you guys are seeing it in better time now. Now, what can we do with this? What we can do is we can start changing this to do mouse movements. I don't know why I do this kind of redundant piece here. So these two counteract each other anyways. So let's just remove them, clean up our code, and re-upload. Now, while that's happening, okay, so back to our screen here. Watch the mouse, because that's all it's doing. Or I should save this for after, but watch the mouse where it is. Let's say it's roughly dead center of the screen. When we click this one, it moves up. When we click this one, don't know what this one does. Moves left, this one moves right. So it's just discrete movements. Okay, and finally, let's make this more interesting. Let's take button 3, that's the orange button, and make it, say, Control N. I don't know what that does, but let's Control Paste. It would be Control V. And let's copy this, and we'll put our cursor here. Control key. This open. Let's see if that will work. Okay, I don't think that'll work. Let's just set it up exactly how they have done it. And we're back. Okay, so we had our... Uh-oh, what's happening? this. Okay. I should have stopped while I was ahead with the mouse presses, but let's finish this up. Okay, so 1, and it moves. 2, finally 3. And for some reason, it is stuck detecting it. I think what's happening is my resistors are touching. Okay, hang on just a moment. I suspect I know what's wrong. Okay, so super simple. What was wrong is over here. We have the press, but we didn't release it. Now, previously we had this button right, was it? Button type? Keyboard right function that just presses one key, releases it. But for pressing, if I just hold down Control V, it will repeatedly, print it out as we had before. So I think this is the final time. Let's upload and let's hope this works. Okay, so fingers crossed. We have button 1. That should move it on the vertical axis. Horizontal, I mean. Yes. So left and right, that looks pretty good. Once in a while, it seems to be jumping more than once, which isn't ideal, but I think it's my shoddy wiring. And finally, let's put our cursor here, Control paste once. See, it is doing it twice sometimes. I think what I should be doing is doing a slight delay after each of these. That way it won't do things twice, but that depends on what you need it for. So what we have here is a 3-button, and I'm calling it a stream deck because that's what people seem to want to build these for. In case you are streaming on Twitch or something, people want to be able to issue key combinations very quickly to do whatever they do. But you can see how this can be used for all sorts of things. If you want to, I suppose this can be a mouse all on its own with the left and right click. and if you have a sensor to move the keys. But for me, what I'm thinking about using it is just a couple longer commands. If you do some digital art, if you have something on the side that can quickly toggle between, say, the eraser and the pen or different brushes, that will be really, really useful. So, well, actually, that's not a bad idea. Something you might want to do afterwards is put in a potentiometer. So a potentiometer is basically a dial, and you can use the dial to adjust various. Well, when the Arduino takes in a potentiometer, it'll get a number, say between 0 and 100, and you can assign it values. So you might move the keyboard um, left and right according to that. And I was just thinking, digital painting wise, it might be useful to have a couple of these buttons to switch, say, paintbrush 1, paintbrush 2, and uh, eraser. And then you might have a potentiometer for brightness, for different colors of the brushes. So you want to darken or lighten the color. But basically, if you want to use this as a stream deck, if you want to use it as like a makeshift mouse or some sort of painter tool, that will be helpful. I will be putting this up on, I'll be putting up this code on GitHub, of course. I'll also link to the schematic as well that was on the page we saw earlier, because that was, if I saw that from the start, this would have taken much less time. This was much more frustrating than I thought it would be. But honestly, it was all my fault. Like, I didn't follow the guides at the start. I wanted to cheap out on a few resistors for really no good reasons. These are literally pennies each. But oh well, it is what it is. So thanks for watching, guys.